Alright, let's start 9.8. It is power series. So guys, in 9.1 through 9.6 we talked about the divergence or convergence of a series, right? So we used 10 different tests to determine the divergence or convergence of a series. Let's start what we call the power series now. Definition of power series. Okay, now if x is a variable, then an infinite series of this form is called a power series. Alright guys, have a look. You have a series here. an is some function of n, and then you have x to the power n. This is the simplest power series. More generally, guys, an infinite series of this form is called a power series centered at C, where C is a constant. Alright guys, so basically, if you see an infinite series of the form an is some function of n, okay? X minus C to the power n. That is the more general definition of a power series. Now, it's very easy to determine the center of a power series, okay? All you have to do is pay attention to the parentheses x minus c, and the value c, the constant c, is the center of the power series. So guys, this one here is actually a subset of this, right? Because when c is 0, you get x to the power n. So for this power series, guys, center is 0. Whereas for this power series, center is the constant c. Alright? Now, have a look at this problem. Find the center of the following power series. Guys, don't you agree that this is a power series? You will if I wrote this as sigma n equals 0 to infinity. Now, I'm going to rewrite this as 1 over n factorial times x to the n. So this component here, this is your an. Okay, this component is your an. This is x minus c to the power n. You don't see a c there, so the center for this power series is 0. Alright, so the next one is written explicitly in the right form. This quantity here is an. This is going to be x minus negative 1. Okay guys, why? We need it in the form x minus c to the power n. So when you have x plus 1, it is actually same as x minus negative 1. So the center for this power series is negative 1. Right? So if you have x plus 1, the center is negative 1. How about this? So this is your an, and look at this, and the center for that is 1. X equals 1, right? Okay, so you have now found the centers of 3 different power series, okay? Here, guys, the center is 0 because x minus 0 to the power n, so c is 0. Here the center is negative 1, and here the center is 1. Alright guys, the goal of this topic is to find the radius and interval of convergence of a power series. So first, let's talk about the domain of a power series. So the goal is to look at the radius and interval of convergence, okay? A power series in x, a power series which is written as a function of x, can be viewed like this. F of x equals summation a n x minus c to the n. And the domain of f is the set of all x for which the power series converges. Okay, the domain of f is the set of all x values for which the power series converges. So guys, in algebra, when you were given a function f and asked to find the domain of it, you said the domain of f was the set of values of x for which the function was defined, right? But here, guys, in the case of a power series, the domain of f is the set of all x for which the power series converges. Now, determination of the domain of a power series is the primary concern in this section. Now, there's one thing you must know. Every power series converges at its center. Every power series converges at its center. And you may ask why. Here's the reason. So the center is C, right guys? So evaluate the power series at x equals C. Okay, go to the power series, wherever you see an x, replace it by the center denoted by C. C is a number, okay? So let's call the center C here. So take the infinite series sigma n equals 0 to infinity an. The x is replaced by C, okay? So you get, when you simplify this, this is sigma n equals 0 to the power infinity an times 0 to the power n. Now, if you expand it out by plugging in values for n, when n is 0, a sub 0, 0 to the power 0 will turn out to be 1. Okay? Guys, that's a special case, right? 0 to the power 0. Now, when n is 1, this becomes a1, 0 to the power 1 is 0, so the term is 0. When n is 2, that's a2, 0 squared is 0. So all the other terms are 0. So at the center, guys, when you evaluate the power series, it will be equal to a sub naught. And that's why the power series is convergent at its center. You're not going to get an infinite sum. The power series is convergent at its center. It's a finite sum. All right? Now, so we all know every power series converges at its center C. The question is, where else does it converge? What are the other x values for which the series is convergent, right? So guys, the domain of a power series can take three forms. By the way, remember I talked about the domain of a power series. What is the definition? The domain is the set of all values of x for which the series converges. Okay, so the domain of a power series can take three forms. It could be that the series is convergent at a single point. Now, if it is convergent at only one point, that point has got to be its center. Okay, if it's convergent at one point, that point is its center. Or it could be that it's convergent for x values in the neighborhood of its center, to the right of the center and to the left of the center. Or it could be that the series is convergent for all x values. In other words, the domain would be negative infinity to infinity. So the domain of a power series can take three forms. It could be that it's convergent at a single point, namely its center, or it's convergent So guys, that's what I have expressed here under convergence. So you know how to figure out the center now. Let's talk about the radius of convergence. Okay, let's denote the radius of convergence with the uppercase R. The number R, the uppercase R, is the radius of convergence of the power series. Okay, if the series converges at its center, then the radius of convergence is 0. You might ask, how is that? R is 0, right? Now, radius of convergence is the distance between the center of the power series and the largest x value or the smallest x value for which the series converges. Alright guys, so let's go back here. So guys, if the power series is convergent only at its center, what's the distance between the center and the center? Isn't the distance 0? So that's what I'm saying here. If the series converges only at its center, the radius of convergence is R equals 0. Now, if the series converges for all x, then the radius of convergence is R equals infinity. So guys, come back here. So this is your center. If the series is convergent for all x values, what's the distance between the center all the way up to infinity? Isn't that infinity? So that's going to be the radius of convergence. Okay guys, so in some cases the radius of convergence is 0. In the other cases the radius of convergence is infinity. In some other cases guys, the radius of convergence is a finite number. I will show that to you in an example. Okay, the set of all values of x, okay, the set of all values of x for which the power series converges is the interval of convergence of the power series. Okay, So guys, in the next question, what I want you to do is find the radius of convergence. Now, before you start it, tell me what the center is. Center in this case is, remember, this is your a, and x minus c to the n. C is 0. Alright? It's important that you figure out the center, because when it comes to the radius of convergence, you have to measure the distance from the center. Alright? So guys, in order to determine the radius of convergence, what we are going to do is do ratio test. Okay? So I want to do the limit as n goes to infinity of, we covered ratio test, right guys, along with the root test. If you have forgotten how ratio test works, please go back and study that up first. Okay, limit as n goes to infinity, absolute value of a n plus 1 over a n, which is limit as n goes to infinity. What's a n plus 1? That's going to be n plus 1 factorial x to the power n plus 1, right? Divided by a n. This is your a n, right guys? N factorial x to the n. Do you understand how I got a n plus 1, guys? I went to this and replaced all my n's by n plus 1. Now, before we go any further, guys, what I want you to do is I want you to rewrite the larger factorial using the smaller factorial. So what I'm going, n plus 1 factorial is actually n factorial times n plus 1. Copy down the terms containing x. Now, and of course I have n factorial in the denominator. Notice that this n factorial cancels that n factorial. Okay, now, where do we have an extra x, guys? Okay, I noticed that we will have n plus 1 remaining. This is x to the power n plus 1. This is x to the power n. Where do we have an extra x? We have an extra x in the numerator. Right? Okay. So now, what is that going to be? Now look, guys. This is a product. Okay? So absolute value of n plus 1 times x. If n plus 1 is positive, you can remove that from the absolute value sign. So this is going to turn into limit as n goes to infinity of, okay, I took the absolute value, n is always positive, so absolute values are not necessary. Now we don't know what x is. Be sure to keep your x inside absolute value signs. Okay, now take the limit. Limit of that is going to be infinity, and this is going to be absolute value of x, right? So guys, what is the overall limit? That is going to be infinity, which is bigger than 1, right? So guys, no matter what x is, the limit of the ratio is going to be infinity, which is bigger than 1. And what does the ratio test tell you? If the limit is bigger than 1, the series diverges. Or if the limit is equal to infinity, the series diverges, right? Okay, so guys, so let me go back here. We did the ratio test. We tried to find the limit of the ratio as in this fraction, right? Okay, so we tried to find the limit of the ratio. We did our math, and we ended up with infinity for the limit of the ratio. No matter what x is, infinity times x is going to go to infinity in this case, because absolute value of x is a positive number, right? It's not a negative number. Okay, infinity times absolute value of x is infinity, because we know absolute value of x is a positive number. Okay, now let me go back up and say here. Now, we know that the power series converges at its center, c equals 0. So we are doing the ratio test for x not equal to 0. Okay, because when x is equal to 0, guys, we know that it's convergent. So we are trying to find what happens to the power series when x is not equal to 0, right? So we are doing the ratio test. And the ratio test tells you no matter what x is, no matter what positive value x is or what negative value x is, the absolute value of x is positive. Positive times infinity is infinity. Then you might say, what about when x is 0, right? Infinity times 0 is an indeterminate form, but we know for a fact that x equals 0 happens to be the center, and every power series converges at its center. So here we know x is convergent at, beg your pardon, here we know the series is convergent at x equals 0. And for other values of x, the limit of the ratio is infinity, so the series diverges. So I want to make a note for you. Therefore, by the ratio test, okay, the series diverges for all x except x equals 0. Okay, so the series converges only at its center. Okay, the series converges only at its center. Alright guys, so what is the radius of convergence? Here is the center. What is the distance between the center and the only x value at which it is convergent? So you're trying to find the distance between the center and x equals 0. Isn't the radius of convergence therefore 0? So remember guys, if a power series is convergent only at its center, then the radius of convergence is 0. Okay, find the radius of convergence of this power series. Okay, what's the center here? Center is x equals 2. Got it? So we know that the power series converges at x equals 2. So let's observe for all values of x not equal to 2. Okay, do the ratio test. Okay, do ratio test. So that gives you limit as n goes to infinity of an plus 1 3 times x minus 2 to the power n plus 1 over an. Okay guys, this is very simple. The 3's cancel out. So limit as n goes to infinity, we have an extra x minus 2 in the numerator. Now, you cannot remove that from absolute value signs because we don't know what x is. Alright guys, limit of the absolute value of x minus 2 as n goes to infinity is simply absolute value of x minus 2. No change because that does not depend on n. You are not going to plug in for n anywhere. Alright, so now for what values of x does the series converge? Because we're trying to find the radius of convergence, right guys? So look, we did the ratio test. Have a look at this carefully guys. We found that the limit of the ratio, ratio as in this fraction an plus 1 over an, the limit of the ratio is absolute value of x minus 2. Notice that the limit here is not a number guys. So we are not able to say directly whether the series is convergent or divergent because we know if it turned out to be a number, if the number is bigger than 1 it's divergent, if the number is smaller than 1 it's convergent, right? But the limit of the ratio is not a number. So what we can say is, by the ratio test, the series converges when the limit of the ratio, in other words, when the absolute value of x minus 2 is less than 1. So you take the limit, whatever limit you get here, and make it less than 1. Okay, now solve for x. Remove the absolute values by sandwiching x minus 2 between negative 1 and 1. Now it's a double inequality, add 2 everywhere. Okay, so what do you get? You have x in the middle, 3 here, and 1 here. Alright guys, we are not ready to talk about the interval of convergence yet. All I want you to do is compute the radius of convergence. Okay guys, so draw a number line to help you there. What is the center in this question? The center is 2. And then we know that x converges between 1 and 3. To find the radius, guys, start from the center and go to the largest value, or start from the center and go to the smallest value of the interval. What is the distance? This distance is 1, right? So r, in other words, the radius of convergence of this problem is 1. Okay? Next one. Find the radius of convergence of the next power series. Okay, where is the center? The center here is x equals 0, or you can say c equals 0. Okay, it's the same thing. Alright guys, so we are going to do the ratio test for x not equal to 0. Do ratio test. Okay, you will always start off with the ratio test. So here we have limit as n goes to infinity of the absolute value of the ratio. Limit as n goes to infinity. Hey guys, go ahead and replace n by n plus 1 carefully. So it's going to be negative 1 to the power n plus 1, x to the power 2 times n plus 1, then add 1, 2 times n plus 1, then add 1, factorial. Okay, that is your an, guys. Now, beg your pardon, that is your an plus 1. Now divide by an. Flip this, so you get 2n plus 1 factorial over negative 1 to the n, x to the 2n plus 1. So dividing by an is same as multiplying by its reciprocal, right? That's what we did here. So here it's going to be limit as n goes to infinity of okay guys, you have an extra negative 1 in the numerator. It really doesn't matter guys, when you absolute value the negative 1 in a product, that disappears, right? Now when you tidy this up, this is going to be x to the power 2n plus 2 plus 1 outside, so that's 2n plus 3. Here 2n plus 2 plus 1 outside, 2n plus 3 factorial. And here 2n plus 1 factorial. Now look, we cancel the negative ones, so you get x to the power 2n plus 1. What do you get when you simplify? That's my question. Alright guys, so we have limit as n goes to infinity of negative 1 times. Now how many extra x's do you see in the numerator? Here this power has 2n plus 3, this power has 2n plus 1. The difference in their powers is 2, so you're going to have x to the power 2 in the numerator. Now, then we have to deal with factorials. Of these two factorials, 2n plus 3 factorial is the larger one. So guys, what we are going to do is rewrite the larger factorial using the smaller factorial in question. The smaller one in question is 2n plus 1 factorial. So if I use 2n plus 1 factorial here, it's going to be 2n plus 1 factorial, and then I have 2n plus 2, then 2n plus 3. Does it make sense? Because you've come up to 2n plus 1 factorial, you have to reach 2n plus 3 factorial. That means you have 2 more terms, 2n plus 2 times 2n plus 3. Okay, so guys, if you write the larger factorial using the smaller factorial in a fraction, the smaller factorials will cancel out. Okay, now x, I know that we don't know what x is, but no matter what x is, x squared is positive, right? Except of course when x is 0. But we are doing this for x not equal to 0. We know it's definitely convergent at its center, x equals 0. Okay, for x not equal to 0, x squared is always positive, so absolute value signs around x squared are not necessary. And negative 1 absolute value is positive. This is going to be x squared times the limit as n goes to infinity of 1 over 2n plus 2 times 2n plus 3. N is always positive, guys, so absolute value signs around those factors are not necessary. Now you might ask why I pulled x squared out of the limit. Look, the limit depends only on n. It does not depend on x, right? So x acts as a constant when it comes to evaluating the limit. So you can always pull a constant out of the limit sign. So guys, this is going to be x squared, and of course this limit is going to be 0. The overall limit is 0. So what do we have? We did the ratio test. Look, we did the ratio test. The limit of this ratio, an plus 1 over an, is what we have now. The limit of the ratio is actually 0, which is less than 1. In this case, guys, we have a numerical value for the limit of the ratio. So guys, no matter what x is, the limit is 0. No matter what x is, the limit is 0. What does that mean? The limit is 0 no matter what x is. So the series converges for all values of x. Here is your center. No matter what x is, it can be anything positive, it can be anything negative, it can be 0 because it's convergent at its center 0. No matter what x is, the series converges. So guys, what do you think is the radius of convergence? Radius of convergence is infinity. Alright,